SpaceX Flight 10 date just leaked through an official filing, and it's sooner than anyone expected. But that's not even the crazy part. They literally cut a hole into their launch tower and built a brand new connection system that's never been tested before. Will this revolutionary setup finally work, or are we about to witness another spectacular explosion? Let's dive right in. Here's what nobody expected. That Federal Communications Commission filing wasn't just announcing a launch date, it was revealing SpaceX's most desperate engineering gamble in company history. While everyone assumed August 4th was chosen because of Ship 36's explosion damage, the real story runs much deeper. Something happened after Ship 36's explosion that SpaceX hasn't told anyone, and now they're betting the entire program on a system that's never been tested. But why the rush? The answer will shock you. When Ship 36 exploded during its test flight, the damage wasn't just physical, it was psychological. SpaceX engineers discovered something terrifying in the wreckage, something that changed everything they thought they knew about Starship connections. Think about this. Every single Starship test before now might have been compromised by a flaw that nobody noticed. Every explosion, every failure, every setback, all potentially linked to a design problem that was hiding in plain sight. But here's where it gets crazy. Instead of admitting defeat and rebuilding everything, which would take years and cost billions, Elon Musk made a decision that engineering experts are calling either revolutionary or suicidal. They chose to literally cut holes in their billion-dollar infrastructure. Picture this scene: SpaceX workers taking industrial cutting torches to their launch tower. The same tower that took years to build and represents the pinnacle of aerospace engineering. They're cutting precise holes into the lower section of their booster connection system, installing upward-pointing pipes, and welding custom steel frameworks in place. This isn't repair work. This is architectural surgery on a scale never attempted before. The new hybrid system they created combines old and new technology in ways that violate every aerospace engineering principle. Traditional rocket companies spend decades testing new connection systems. SpaceX built theirs in weeks. But here's the part that should terrify everyone. The steel framework they installed was designed to fit Ship 37's connection requirements perfectly. How did they know the exact specifications when Ship 37 was still being built? The answer reveals SpaceX's most closely guarded secret. While chaos erupted at the launch site, something equally dramatic was happening inside SpaceX's assembly building. Ship 37 wasn't just getting engines. It was getting the most advanced rocket engines ever created. Raptor vacuum engines designed specifically for the vacuum of space. Here's what makes this significant. These engines are larger, more powerful, and infinitely more complex than anything SpaceX has ever tested. They generate enough thrust to lift entire city blocks, and they're being installed on a spacecraft that will be connected to a completely untested system. The question keeping SpaceX engineers awake at night: what happens when you fire the most powerful engines in history through a connection system built in weeks? But there's something even more disturbing. Recent reports suggest Ship 37 needed an engine replacement after its static fire test. Why would a successful test require an engine swap? The answer reveals a deeper problem. August 4th seemed impossible just weeks ago. After Ship 36's explosion, aerospace experts predicted delays of at least 6 months. So how did SpaceX compress their timeline so dramatically? The answer reveals their most controversial decision yet. They chose to develop everything in parallel. While engineers were cutting holes in the launch tower, other teams were simultaneously installing engines, testing systems, and preparing for launch. This approach violates every safety protocol in aerospace engineering. Traditional rocket companies test each component individually, run extensive reviews, and implement changes gradually. SpaceX is doing everything at once. But here's what's really disturbing. If any single element fails, the entire system collapses. The connection system, the engines, the timeline, everything depends on everything else working perfectly. What are the odds of success? Nobody knows because this has never been attempted before. Everyone noticed the August 4th date, but here's what they missed. SpaceX has launched almost every recent Starship test on a Thursday. August 7th is a Thursday. This isn't coincidence. Its strategy. Thursday launches give SpaceX entire weekends to analyze data, plan next steps, and prepare for potential failures. But there's a deeper reason for the Thursday preference that reveals SpaceX's true intentions. SpaceX isn't just launching rockets, they're launching a revolution. Every Thursday launch is carefully timed to maximize media coverage, investor confidence, and competitive advantage. They're not just testing technology, they're reshaping the entire space industry. But this strategy comes with massive risks. If their August gamble fails, the explosion won't just destroy a rocket, it could destroy SpaceX's credibility forever. While SpaceX races toward their August deadline with untested systems, Boeing's Starliner sits grounded with no clear timeline for return. Recent NASA statements reveal that Starliner's next flight will likely carry only cargo, not astronauts. The contrast is staggering. Boeing can't safely fly astronauts on a spacecraft they've been developing for over a decade. SpaceX is about to test a revolutionary connection system built in weeks. But here's the terrifying parallel. Both companies are pushing their systems beyond safe limits. Boeing's desperation led to multiple failures and safety concerns. Is SpaceX's rush toward August 4th following the same dangerous path? The difference is that Boeing's failures were gradual and containable. If SpaceX's gamble fails, the explosion will be visible from space. Everything leads to one crucial moment: Ship 37's static fire test. This single test will determine whether SpaceX's revolutionary approach was genius or catastrophic failure. Imagine the scene. Ship 37 mounted on their hybrid connection system, all Raptor engines firing simultaneously, generating thrust equivalent to lifting a skyscraper. The entire spacecraft will be fighting against the connection system, testing every weld, every bolt, every engineering decision made in desperation. But here's what makes this test truly terrifying. It's not just about whether the system holds together. It's about whether SpaceX can prove that rapid innovation works at the highest levels of aerospace engineering. The stakes couldn't be higher. If it succeeds, SpaceX validates their entire approach to space exploration. If it fails, the explosion could end the commercial space industry as we know it. If SpaceX's August 4th timeline fails, the consequences reach far beyond one company. NASA's Artemis program depends on Starship for lunar missions. The International Space Station's future relies on reliable commercial crew vehicles. The entire vision of affordable space travel hangs in the balance. But there's an even darker possibility. If SpaceX fails spectacularly, it could trigger a regulatory crackdown that destroys the entire commercial space industry. Government agencies are already questioning whether private companies can safely handle such advanced technology. One explosion could set space exploration back by decades. SpaceX's August 4th gamble represents more than just a launch date. It's a fundamental test of whether revolutionary engineering can work in the modern world. Traditional aerospace companies spend years on incremental improvements. SpaceX is betting everything on radical innovation completed in weeks. What happens next will determine not just the fate of Starship, but the future of space exploration itself. We're about to witness either the birth of a new era in aerospace engineering or the most expensive failure in human history. The question that will define the next decade of space exploration isn't whether SpaceX can reach August 4th. It's whether their revolutionary approach to engineering can survive contact with reality. And we're about to find out. So here we are. SpaceX's August 4th gamble isn't just about launching a rocket. It's about proving that impossible timelines, revolutionary thinking, and calculated risk can reshape entire industries. We've seen them cut holes in billion-dollar infrastructure, install untested connection systems, and bet everything on engines that have never been fired together. The static fire test will happen soon. Ship 37 will either validate SpaceX's approach or create the most expensive fireworks show in history. But here's what I find fascinating. Regardless of the outcome, SpaceX has already changed the game forever. Think about it. While Boeing struggles with basic safety on decade-old technology, SpaceX is rewriting aerospace engineering in real time. They're not just building rockets, they're building the future. What do you think? Will SpaceX's revolutionary approach pay off, or are they pushing too far too fast? And more importantly, What does this mean for the future of human space exploration? The next few weeks will be absolutely critical. Make sure you're subscribed because when that test happens, you'll want to be the first to know what it means for all of us. The future is being written right now, and it's happening faster than anyone thought possible. Game over! SpaceX just revealed Starship's drone ship legs landing, and it changes everything. How is this even possible? Everyone thought Mechazilla arms were the only way, but SpaceX just dropped a bombshell. A 400-foot Starship landing on floating platforms with deployable legs? The FAA reveals 145 flights per year on drone ships worldwide. But why did SpaceX do this? What makes it so special? Let's dive right in. Here's the problem nobody talks about. SpaceX just announced 145 Starship flights per year. Let that sink in. The entire global space industry launched 223 rockets total in 2024. SpaceX wants to fly Starship more than half that number with a single rocket design. But here's the twist that breaks everyone's brain. Most of these won't be landing back home. Think about it. Every rocket faces the same brutal physics problem. You can either save fuel to fly back to your launch site, or you can use that fuel to carry maximum payload. There's no middle ground. It's like choosing between a sports car that looks fast or one that actually goes fast. You can't have both. For Falcon 9, this choice is manageable. The booster weighs 25 tons and needs about 30% of its fuel to return to the launch site. But Starship? We're talking about a 100-ton vehicle that's 4 times heavier. The fuel penalty for returning home would cripple most missions. So what's SpaceX's solution? Don't come home at all. Here's the problem nobody talks about. SpaceX just announced 145 Starship flights per year. Let that sink in. The entire global space industry launched 223 rockets total in 2024. SpaceX wants to fly Starship more than half that number with a single rocket design. But here's the twist that breaks everyone's brain. Most of these won't be landing back home. Think about it. Every rocket faces the same brutal physics problem. You can either save fuel to fly back to your launch site, or you can use that fuel to carry maximum payload. There's no middle ground. It's like choosing between a sports car that looks fast or one that actually goes fast. You can't have both. For Falcon 9, this choice is manageable. The booster weighs 25 tons and needs about 30% of its fuel to return to the launch site. But Starship? We're talking about a 100-ton vehicle that's 4 times heavier. The fuel penalty for returning home would cripple most missions. So what's SpaceX's solution? Don't come home at all. Let's break down what 145 annual flights actually means. SpaceX's Falcon 9 is already the world's most flown rocket with over 100 launches per year, but Starship carries 5 times more payload. Do the math. We're talking about more cargo to space in 1 year than the entire history of spaceflight combined. Here's where it gets crazy. The FAA documents reveal landing zones spanning from the Pacific to the Indian Ocean. This isn't just about rocket recovery. It's about creating a global space transportation network. A Starship could launch from Texas, deliver cargo to the International Space Station, then land on a drone ship near Australia. Another mission from Florida could service lunar operations before touching down in the Pacific. But executing this vision requires something unprecedented, a fleet of next-generation drone ships positioned around the globe. These aren't the relatively small platforms used for Falcon 9. We're talking about massive vessels, possibly 3 times larger, equipped with precision guidance systems and specialized handling equipment. Here's where SpaceX's strategy becomes devastating for their competitors. While Blue Origin is still trying to reach orbit, while China experiments with net-catching systems that look impressive but face massive scaling challenges, while Europe's Ariane 6 doesn't even attempt reusability, SpaceX is building a global recovery network. The technical barriers are enormous. These drone ships need to operate thousands of miles from shore, navigate complex international waters, coordinate with global logistics networks, and catch rockets that dwarf anything that's ever attempted ocean landing. The investment required is staggering. The expertise needed doesn't exist anywhere else. But here's the kicker. SpaceX already has the foundation. They've been perfecting drone ship operations for nearly a decade with Falcon 9. Booster B-1067 just completed its 29th landing, a record that seemed impossible just 5 years ago. Now they're scaling that expertise to a vehicle 4 times larger and infinitely more complex. The FAA documents reveal something called horizontal Starship delivery. After landing vertically on the drone ship, Starship would be gently lowered to horizontal using specialized equipment right on the platform. This solves multiple problems simultaneously. First, it reduces stress on the vehicle during ocean transport. A horizontal rocket is much more stable in rough seas than a vertical one. Second, it enables faster turnaround times. Instead of waiting for one drone ship to return to port, SpaceX can position multiple ships in rotation. While one is sailing back with a recovered Starship, others are already in position for the next missions. Think about the implications. This creates an assembly line of space transportation. Launch, land, recover, refurbish, repeat. The economic efficiency could drop launch costs to levels that make entirely new industries possible. Space manufacturing, orbital tourism, asteroid mining. These aren't distant dreams anymore. They become practical business opportunities. But here's the detail that exposes SpaceX's true long-term thinking. Every challenge they're solving for drone ship operations directly applies to Mars missions. Landing legs that can handle Earth's harsh ocean environment will be essential for Mars operations where there's no infrastructure. Precision guidance systems that can hit a moving target in rough seas will be crucial for landing on an alien world with no GPS or ground control. The horizontal transport system being developed for drone ships could revolutionize how equipment is moved on Mars. The international cooperation required for global drone ship operations is practice for the unprecedented coordination needed for interplanetary missions. SpaceX isn't just building a rocket recovery system.